So today we're going to cover relation, which is short for relationship. It is just a relationship or a connection between two variables. That is all it is, a relationship or a connection between two variables. So you have one thing, you have something else, it's a connection between them. Here's an example, because we've actually done this already. Do you remember the proportions we did? How you had like real life, like the real world in miles, and then you have a map that's scaled and it's in centimeters. Do you know what I'm talking about? Centimeters compared to miles. It's just a connection between those two things and the connection that they have. That's all it is. It's just a relationship between two things. What we're covering today are all these different ways that you can represent them. So all the different ways that they can look. So there are 4 different ways. So the first one is ordered pairs. Those go in parentheses and it's one number, comma, another number. It's just a relationship between those two numbers. So I just made one up as a quick example so that you can see what they look like. So for example, ordered pairs would look something like that. And I'm just going to write up a list of them, and that would be the relation. So that's what ordered pairs look like. You've seen those before? Yes, it's X comma Y. Okay. This is very, very basic. That's really all that there's. Those are ordered pairs. I don't have anything else to say about them. It's in parentheses, one number, comma, another number. All right, you can also do a table, which you can draw it vertically or horizontally. It doesn't matter. But we'll have our table X, Y, and I'm just going to use the exact same example numbers so that you can see how it looks as ordered pairs, like versus a table. You're just going to take, for example, this -1, 3 and put it on the table like that. That is literally all it is. I'm just going to list out all the rest of these. Now, technically, the X values should go in order from smallest to biggest, but I'm not going to mark it wrong if you don't, because for heaven's sake, I mean, that's all. You're just representing the relationship between the variables. That's all it is. So like technically the -2 should have been first, and then the -1, and then the 4, and then like they go in order, but it's fine. All right, and then we have a mapping. You'll have to let me know if you've seen these before. I kind of like the mapping. It's sort of like drawing a picture. So I like when it's a picture. What you're going to do is draw these two like ovals. And this one is for all the X's, and this one, it's like all the X's live here and all the Y's live here. You're like creating a space where they live. Here's the only thing with these, because it's a lot like the table. You don't repeat the numbers though. That's the big thing with the mapping. It's just make sure you don't repeat them. So for example, -1 to 3, you put -1, you put 3, and you connect them with an arrow. It's just like drawing a little picture. Have you seen those before? Like with the ovals and the arrows? Okay, cool. Those not new. I like drawing. It's just a little picture. Just make sure you don't repeat anything. All right, then we have 4, 2. So 4 goes here, 2 goes here, draw an arrow. And then when you look at the next one, look it, do you see how it's 4, -3? Don't write another 4, -3. Yep, exactly. I mean, I'm not going to take off points if these aren't in order. Technically, they're supposed to be in numeric order, but I will take off if you repeat a number because you're not supposed to do that. And then same with this one. See how it's -2, -3? All I need is the -2 because I already have a -3 over here. And then just draw in that arrow. I like the mappings. Those are my favorite one. This is a little picture. And then lastly, you can do a graph. So we're going to draw our coordinate plane. And I think it's a good habit to always label the axes. This one is X, the horizontal one, that's X. And then this is Y. And I didn't make these numbers very big. I kept them small for you. So you would only need to go like 4 in each direction at the most. Have you done this before? Yeah. Okay. I usually print a grid on the paper for you. Like see how here I printed it. I don't know why I didn't print it there. I'm sorry, but they're little numbers, so you'll be okay. Let's review the quadrants because they're numbered. Where is quadrant 1? Top right, good. This is quadrant 1. And you go counterclockwise. So this is 2, and then this is 3, and then this is 4. So you have to be able to, like, when I'm like, hey, what quadrant is this point in? You have to be able to tell me 1, 2, 3, or 4. Or if it lands on the axes, you have to be able to say, like, it's the x-axis or it's the y-axis. All right, so let's plot these. -1, 3. You're going to go negative on the x-axis and then 3 on the y-axis. So that would put you right here in quadrant 2. I think I put 1 in each quadrant so we could practice that. What quadrant would 4, 2 be? Quadrant 1. You go 4 on x and then 2 on y. So like right 4 up 2. Do you think of like directionally? What quadrant would 4, -3 go in? The 4th, you would go right 4, down 3. So like 4 in the x direction, -3 in the y direction. And then this would be quadrant 3. So you would go left 2, down 3. What we're headed towards is slope. Do you remember slope? Like a line up 3/2 kind of thing. Okay, that's like the direction we're headed next unit. All right, little bit of vocabulary. So those are the 4 ways you can represent a relationship between the variables. Vocabulary for the x coordinate, you have input. So that's what you're like plugging in. It is also the independent variable. Independent, so it's kind of like the one that's in charge. And then we also use the word domain to describe all of the inputs. So domain would be all of like the x values. Yeah, see, okay, yeah, yesterday everybody knew that too. That's awesome. So if we like take those 3 words and relate them to the y coordinate, instead of input, it would be, yeah, output, dependent. So what that means is the y value depends on the x value. Like what you get out depends on what you put in. And then range describes all of the output values. So like what? Yeah, exactly. Like 1 is input, 1 is output. This is not real complicated. You just need to stay awake almost is what it is. So we're just going to practice, showing what each of these look like. Only pep talk I'm going to give about this. Yes, this is a very, very simple concept. So don't go to sleep on me because if you miss one of these on your test, you're going to be upset, right? Like you don't want to miss the easy ones. Can you just close the Chromebook for me, please? All right, so we're going to express this relation. So these 5 points in all the other ways. All right, so for a table, just go ahead and write a table. Let's try and put them in order. Technically, they're supposed to be. So let's try and do at least one where we put them in order. Look at all your x values. Here, I'll just underline them. These should go in numeric order. And careful, it's going to be like the most negative to the most positive. So which one would be the first one? Yeah, good. -3, 4, if we're being like real particular. And then -2, -2. So we did these 2. I'll check them off as we go. -1, 4. 0, -3. Good. And then 3, 2. The y's aren't going to be in order. They just are whatever they are. The outputs are just like whatever you get. And then the mapping, you're just going to draw a picture. So draw a big oval. This is where all the x's live. Draw another big oval. That's where all the y's live. And we're just going to connect them together. The only thing is you can't repeat any numbers. That's it. So -3 goes to 4. -2 goes to -2. -1 goes to 4. So I don't need to write another 4. Just connect it with a new arrow. Yeah, I think I'm going to have to write both of those, right? 0 goes to -3. And then 3 goes to 2. Good. Don't miss them on your test. That's my only like concern is like that everybody's going to be like, wow, this is really easy. And then stop listening and check out. And if you miss one of these on your test, you're going to be so upset. Okay. All right. And then the graph. So we're just going to take these points and plot them. -3, 4. What quadrant would that be in? 2. Quadrant 2, right over here. So -3, 4, and that will be a question on a quiz or test is what quadrant is it in? So you got to be able to say that. This will be in 3, -2 will be right here. This will be in quadrant 2. -1, 4 will be right there. Now 0, -3 is not on a quadrant. Good, you would say y, perfect. You would say y-axis. And then 3, 2. Now, do you connect those? Because I have some people that'll do that sometimes. Don't connect them. It's just 5 random points. It's like a constellation. Okay. This time I gave you a table and we're going to write it all the other ways. So that one I gave you ordered pairs. This time I gave you a table. Same thing though. We're going to take those and write them as the ordered pairs, the mapping, and then I gave you a grid for the graph. So the ordered pairs, it's just in parentheses. So you would have -3, 5. Careful because the table's sideways this time. I oftentimes will make the tables sideways, like horizontal, so that they fit on the paper better. But we're just going to list these out. -1, -4, 1, 4, 1, 0. I'm going to stop reading them because I know that that's annoying. Just go ahead and copy them all down. It's easy, so don't ignore it. You don't want to miss the easy ones, is my pep talk for that. So then for the mapping, again, draw your ovals for the X and the Y. And again, I'll attempt to put them in order, just so that we're being thorough. Or did I put them in? I put the X's in order. I put them in order for you. Look it. See how it goes the most negative to the most positive? Good, I did it for us. Go me. All right, so -3 goes to 5. Yeah, see how there's 2 that are the same? And I think I had a Y value. See how there's 2 5s? Yeah, so just be careful. All right, so -1 to -4. 1 to 4. And then 1 also goes to 0, so you don't write another 1, just, use the same one. 4 to 3, I will need to write both of those. Now 5 to 5, you will need to put a 5 on the X's, but there's already a 5 on the Y's. And I don't know, this does bother some people. Do you see how the arrow is gonna like cross over all the other arrows? I'm sorry about that, if that bothers you. It's okay though, that's allowed to happen. And then 6 to -3. And then again, we're just gonna plot them and I'm just gonna ask you the quadrants, because again, that would be a quiz or test question. You have to say what quadrant. So -3, 5, what quadrant would that be in? 2, good. -3 for X, 5 for Y. And don't connect them, it's just a constellation of points. That would be 3 for this one. They're both positive, so that would be 1, good. Good, 1, 0 would be right here. So that's on the X-axis. And if you look, it's really tiny, but it is labeled there. 4, 3 would be in the first quadrant. 5, 5 is also in the first quadrant. Did you plot them already? And then 6, -3 is in the fourth quadrant. Good. Cool, good job, guys. Don't connect them. It's just a constellation. All right, and then this last one's our word problem, all right? Movie tickets cost $12 per person. We have people and we have money. So let's think about this. When you go to the movie theater, does how much you pay depend on how many people you bring? Does that make sense? So money depends on, like how much you spend depends on how many people you bring. So money is dependent on people. How much money you spend, well, it depends on how many people you bring. Does that make sense? Because if you say it in your head that way, like it will make sense one way and it won't make sense the other way. Okay. So make a table. So we're going to make a table X and Y, show a relationship. That's what we're doing here between the variables for groups of 4, 7, 11, and 15 people. So if we bring 4 people, 7 people, 11 people, or if you're really nice and you bring 15 people to the movies, how much would it cost? Yeah, it's going to be a lot. Well, how do we figure out how much it will cost?
You're gonna multiply 12 times like 12 or like.
Yeah, exactly. We're not including like popcorn or anything like that. You're just going to multiply each of these by 12. So 4 times 12, 48. 7 times 12 be 84. And I'll type these ones in for us. 11 times 12 will be 132. Yeah, 144 is 12 times 12. Go ahead.
There's was like a budget with the money we did with there. There's a maximum limit.
So that's a really good question. Here, let me write up the last one. It's 180. So if you had some sort of budget, we actually did ones like that last unit. Do you remember how we had like a less than or equal to? There was one on your test like that, whatever. So that would be an inequality that you would have to set up. And then we're just going to graph these. We want to label our X and Y axis. So X is independent. That would be people. And then the output is dependent. That would be cash money. And we're just going to plot those. So it was 448. Now, 48, it's not going to be perfect. You're just going to get it as close as you can, like just a little bit below 50. When in doubt, if you just make the point larger, do you know what I'm saying? Like it'll take up more space. That's my like go-to with that. All right, 784. So again, 84 would be like between 80 and 90. Just do your best. Oh my gosh, I was going to bring that up. Hold on 1 second. You're ahead of me. 132 will be like right about there. And then 180 is actually exactly on a nice point. Now don't connect them, but where I'm headed with this is, do you see how it's linear? It's a line. That's because the more people you bring, the more money you spend. And if you brought 0 people, what would you spend? Yeah, do you see how it would connect like that? Don't connect them, but like foreshadowing, that's where we're going to be headed like in the next unit.